In this lesson video, we're going to be looking at mental addition strategies. So that means we're going to be learning how we can add pairs of numbers in our head without using a written method. We're first going to start at looking at some different strategies that will help you to build up this skill. So I'm going to look at how we might use resources to help you to visualize how to be able to add those numbers in your head. So it might mean that you may have to start by using resources and maybe jotting them down, but this will help you to be able to build up your visual strategies. There is a free downloadable worksheet that is available to do alongside this video. On that worksheet, you have a green, yellow and blue route. So the green route is our entry points. That's the easiest route. So start there if you haven't got many mental addition strategies yet. If you're feeling a bit more confident, or if you find the green route too easy, you can go to the yellow route, and the blue route is then the most difficult. We would expect you to be at green route in year 3. In year 4, we would expect you to be on green or yellow, and in year 5, we would expect you to be on yellow or blue, and in year 6, we would expect you to be on blue. As with anything, if you are in year 6 but you need to go to green route, that's absolutely fine. You go to the strategy that helps you, and then you can build up as you get more confident. The final chapter is the number bonds, which is the last activity on your worksheet. You can either have a go at doing either green, yellow or blue, or you might want to have a go at all 3. One of the first things to understand when we're thinking about mentally adding is we need to understand about place value. So if you haven't watched the place value video yet, there is a place value lesson available with free worksheets as well. Now you need to understand that, for example, 10 ones can be exchanged for 1 10. So you can see on the right here I have 10 ones, and I can actually exchange my 1 10 for 10 ones, and I can regroup my 10 ones for 1 10. They are the same value, but as soon as I get to 10, I would swap them up for 1 10. Now the same can be said for 10s. Once I've got 10 10s, I want to swap them up for, I'm going to regroup them for 100. And once I've got 10 hundreds, I can regroup them and I can swap it for 1,000. So we don't ever want more than 9 of a 1, a 10 or 100. As soon as we get to 10, we're going to swap them. So the first part of helping you to build a visual understanding, so that means getting a picture in your head when you're adding in your head. So when you're mentally adding, you should be able to visualize what you're doing. So I'm going to use some arrow cards here to demonstrate. So for example, if I wanted to add 2 numbers, so if I wanted to add 43 and 12, for example, I might want to use some arrow cards at first. So what I would do is partition them. So I'm going to separate them into the 10s and the 1s. So you can see I have separated my 1s. I've got a 3 and a 2 here. And if I just add the 1s, I can see 3 and 2 is 5. And then I've partitioned my 43 into a 40 here, and I've taken my 110 out here. And if I add my 10s, you can see I have a 50. So I've taken my original number, I've partitioned my 43 to a 3 and a 40, I've partitioned my 12 to a 2 and a 10, and then I've added my 1s to get 5, I've added my 10s to get 50, and then finally I want to put my 2 arrow cards back together, which would give me 55. So the answer to my original calculation is 55. So when you are starting to build up your strategies, you may want to use an arrow card, or you may want to write out your calculations in a similar way, which I'll demonstrate through the lesson. But this will help you to visualize it. Eventually, I want you to be able to do this in your head. So when you see the number 43 and 12 in your head, I would want you to imagine, okay, I've got the 3 and a 2, that makes 5, and then I've got the 40 and the 10, that makes 50, 50 and the 5 makes 55. What this means is you need a good memory because you have to hold those numbers in your head. So if you struggle with remembering, so for example, if you did this and you did 3 and 2 was 5, and then you forgot that number after doing 40 and 10, that means you need to work on your memory. So doing lots of memory games will really help you to build up your working memory, and that will help you to be able to add and subtract and calculate in your head. Going to look now at how you can even use something like arrow cards for larger calculations and how you can use this to help you visualize. So for example, here I have the number 5,368 and I want to add 3,600. Now the important thing here is to think about all the parts of my number. So I'm going to separate my digits out. So my 5,368 is made up of 5,360 and an 8. And if I separate my other number, you will see that actually it's only got thousands and hundreds. There's nothing in the tens or the ones column. So I have actually less to add. So my 5,000 and my 3,000 together would make 8,000. So I'm going to change this to 8,000. My 300 and my 600 together would make 900. So I'm going to swap that for a 900. And I'm going to pop it on top. My 60 and my 8, there's nothing to add to it. So it's not going to change. It's going to stay exactly the same. When I recombine the number, I can see that it was only my 1,000 and my hundreds digits that changed. And my answer is 8,968. So again, as before, use arrow cards to help you if you need to. To begin with, you might actually use arrow cards in your hands, or you might write using the concept of arrow cards, or you might be able to move to visualizing these in your head. Another method you may want to use to help you to visualize adding mentally, adding in your head, is to use a number line. Now, when you're adding numbers, I would always start with my largest number at the beginning of the number line. So my largest number is 43. So I would write my largest number at the beginning. I would add on to my largest number. And then I'd want to think about my next number. I would want to partition it. So rather than adding 15 in one jump, I would want to add my 10 first. And then I want to add my units or my ones separately. Now you could do it the other way around as well. You might want to add your 5 first and then your 10. Now when you're adding 10, you only need to change the digit that's worth 10. So the only digit that's going to change is the 4 because that is worth 10. So that would become a 5. I'm only adding 1 10, so my 4 is only going to change by 1, and my 1 is not going to change. It's going to stay as 53. Now the next jump, I'm adding in ones, which means it's only my ones digit that's going to change because I'm adding 5 ones. My tens digit will stay the same. So my tens digit is going to stay the same. I'm adding 5 to my 3, so that becomes 58. So here I'm visualizing the largest number at the beginning of a number line. I'm splitting my jump up into tens and ones, and I'm remembering which digit I need to change. The same strategy will also work with larger numbers. This time I'm going to put my 2,430 at the start, as it's the larger number from the pair, and I want to add on my 150, and as before I'm going to break it up. So I'm going to add 100, and then I'm going to add my 50, my 5 tens, and there's no ones to add, so it's just the 100 and the 50. So first of all, I will add my 100, and what I will notice is I've only got 100. If I look at my original number, the 4 is worth 100. So my 4 is only going to change by 1. So the number will all be the same except for the hundreds digit. So 2430 becomes 2530. And now I want to add 50, that's 5 tens. So if I look at my number, I only want to change the number in the tens column, which is my 3. 3 is worth 10. And I need to change it by 5 tens or 50. The rest of my number will stay the same. 3 and 5 is 8, and 30 and 50 is 80. So my answer is 2,580. Okay, that was a quick snapshot of how you can use different strategies. So arrow cards or number lines in your head to help you visualize what to do when you're mentally calculating. If you choose which route you'd like to go through, you can do all three if you want. You can swap backwards and forwards. It's up to you. I'm going to first start by going through all the 3 steps in the green route. Okay, for step 1, we are going to try and add to a 2-digit number. So we have the number 34, and we're first going to try and add the number 3. Now we just have 1 digit here, and that 3 is worth 1. We have 3 ones, which means we only need to add to our ones digit in our 34. So first of all, think about which digit in 34 is worth 1, and we're only going to be adding these 2. So our tens digit is going to stay the same. If I think about it like arrow cards, I've got 30 plus nothing, because there are no tens in this number, and I have 4 plus 3. So my 30 and my nothing make 30, and my 4 and my 3 make 7. And if I regroup my numbers, if we recombine, put my 30 and my 7 back together, I'm going to get 37. So I'm going to visualize the digit that I'm adding with the digit from the other number, which is in the same place. So my 3 and my 4, they're both worth 1. So those are the 2 that are going to add together. I've only got 1 10, which is my 3 tens and my 34. Let's have a look at another example. Okay, so my next example is 34 plus 20. So this time I'm adding 2 tens because my 20 has got 2 tens. So, and there's no ones, so I'm not going to do anything there. So which digit in 34 is in the tens column? Well, it's the 3. So my 3 and my 2, they're going to add together. And if I think about it like arrow cards, my 30 and my 34 is made up of 30 and 4, and then my 20 is just made up of a 20 and no 1. So I can separate, partition my numbers and add them separately. My 30 and my 20 make 50. My 4 and nothing make 4. And then my 50 and my 4 together make 54. So for step 1, I want you to look at the number you're adding to your 2-digit number and think about whether you're going to be changing the digit in your ones column or the digit in your tens column. You're only changing one of the digits in your 2-digit number for step 1. So only one of your 2 digits that you're starting with will change. Okay, have a go at those now before moving on to step 2. For step 2, we're going to be adding, changing both our digits in our 2-digit number. So this time you can see that we've got 22, I've got something in my tens and my 1 column. So I'm going to start with my ones. I've got 2 ones here, and here I've got 4 ones. So these are going to add together. And then I've got 3 tens and 2 tens. These are going to add together. If I try to visualize it like the arrow cards, I can think about my 34 as a 30 and a 4. And I can think about my 22 as a 20 and a 2. Does that make sense so far? I've separated my 34 into 30 and 4. And I've separated my 22 into 20 and 2. And then I can add each line separately. So 30 and 20 is just the 3 and the 2 that I'm adding. 3 and 2 is 5. So that means that 3 tens and 2 tens is 5 tens. And then 4 and 2 is 6. Then I want to add my answers together. So I got 50 in my first answer and 6 in my second answer. If I can visualize those as arrow cards and I put them back together, I have 56. My answer is 56. You could also see over here, I could, the 3 and the 2 make 5, but that's really 50 because it's 30 and 20. And my 4 and my 2 make 6. That makes 56. Whichever way you do it, it doesn't really matter. It's good to get loads of different ways, but it's good to start visualizing how you can add those numbers in your head. Let's just try that with a different number. Let's try 34 plus 35. So I'm going to this time just partition it so you can visualize what you would do in your head. So I'm just partitioning the tens first, and then I'm going to partition my ones. So I'll be adding these together, and I'd be adding these together. My 30 and my 30 is 60, and my 4 and my 5 is 9. Okay, so I've demonstrated it in 2 places there. And when I combine my 60 and my 9, so if I combine these, I get 69. So have a go now at step 2 on your worksheet. See if you can think about partitioning your tens and your ones, adding them separately, and then recombining those numbers, those digits back together to make a new number. Step 3. This time, our ones digits are actually going to get bigger than 10. So what do we do here? So as before, I want to add my ones digits together, and I want to add my tens digits together separately. So I'm going to write out my 30 and my 20, and then I'm going to write out my ones, which was my 4 and my 9 separately. So my 4 and my 9 actually make 13. It makes a number bigger than 1. We've got 3 ones. We've actually also got a 10. If I add my 30 and my 20, I've got 50. So I now need to add my 50 and my 13. I'm just going to write it over here as well. So I've got 50 when I add my tens, my 30 and my 20. And I've got 13 when I add my ones. Okay, now you may be able to just add 50 and 13. But if you're not, what we can do is we can separate our 13. Now our 13 is made up of 10, which was the colour I'm using for my tens, and 3. Okay, so I've just separated this 13 into 10 and 3. So I've now got 50 and 10 and 3. Okay, I've got 50 and 10 and 3. Again, my 50 and my 10 can combine to make 60, and my 3 makes 63. So it might be better to add your ones first. Should we have a go with another example? Let's have a look with the number 37. So I want to add my ones and I want to add my tens separately. Now this time I'm going to add my ones first. My 4 and my 7 make 11. That's got a 10 in it, hasn't it, my 11? It's made up of 10 and 1. So if I add my 30 and my 30 and the 10 from here, I've got 30, 60, 70. I've got 70 and 1, which equals 71. Let me draw it over on the other side. So I've got 60 with my tens, and I've got 11 with my ones, but I can separate my 11 into 10 and 1. So I've actually got 60 plus 10 and 1, which is equal to 71. Does that make sense? So I'm adding my ones, and if I get a number bigger than 10, I need to make sure that I exchange that so that I've only got 1 1 and I've got 1 10, which is going to add to be to my other 2 10s. I've got my 3 and my 3, so I'm going to add my 30 and my 30 with the 10, which came from adding 4 and 7. So have a go at doing that on your worksheet. If you need to use arrow cards or resources or number lines first to help you do so, but see if you can have a go at doing these in your head. So with step 3, your ones digits are going to add to make a number that is bigger than 10. So don't forget to exchange them and to add the 10 with the 2 tens digits in your 2 numbers. Once you've finished that, you can skip right to the end of the video where I'll go over how to do the last activity on your worksheet, which is the number bonds. Okay, so step 1 for yellow root, we are going to be thinking about just altering one of the digits in our numbers. So I have the number 513 and I'm adding 200. Now in my number 200, I've got a 2 in my hundreds place, and I've got nothing in the tens or ones. So that 2 and hundreds is going to add to my 5 from my hundreds column. So the 5 in my hundreds is the only number, that's the only digit that's going to change. So I'm going to just demonstrate it elsewhere as well. I'm going to take my 513 and I'm going to separate it into 500, 10 and 3. And my 500 is going to add to my 200. Then I've got no 10s and no 1s in that number. So my 500 and my 200 makes 700. My 10 plus nothing makes 10. My 3 plus nothing makes 3. So I can add my 700 and my 10 and my 3. If I imagine those as arrow cards, I can layer my 3 on top of my 10 and then layer that on top of my 700. I'm left with 713. If I show you over on the left hand side, when I add my 5 and my 2, I get 7 or 700. The 10 does not change. And my 3, which is my My ones number doesn't change either. It's 713 both ways. Should we have a go at another example? This time we're adding 40. So my 4 is worth 10. So I need to look at the digit that's worth 10 in my 513. So this is the only digit that's going to change. My 5 is not going to change. There's no hundreds. So that's going to stay as 500. My 10 will change. My 1 and 4 will make 50. And then if I look at the what's worth 1, 3 and nothing is 3. If I combine those all together, I've got 553. Let's look at partitioning the number. So my 513 is made up of 500 and 10 and 3. No hundreds to add. I've got 40 to add, and I've got no tens. And we can add up each bit separately. 500 stays the same. 10 and 40 makes 50, and 3 and nothing, that stays the same. And when I add those 3 up, if I imagine them as arrow cards, I put my 3 on top of my 5, top of my 50, and I put my 53 on top of my 500. I'm left with 553. Let's have a go with one final example. So this time I'm just adding the ones numbers. I've got just these two are going to add to make 6. There's no tens, so that's going to stay the same. And there's no hundreds, so that's going to stay the same. Let's do it if we were to partition it. So 513 is made up of 500, 10 and 3. I have no hundreds to add, I have no tens to add, and I've got 3 ones to add. So that stays the same, that stays the same, and this changes, and both add to 516. Okay, I hope that makes sense. Have a go on activity 1, on step 1 on your yellow route now, before we move on to step 2. So in step 2, we're adding 2 pairs of 2-digit numbers, and we're going to have a look at how we would partition these. So as before, we're still going to separate or partition our numbers. So our 7 and our 9 are going to add together. And then we're going to separately add our tens digits. So you can see I've got my 47 there. And I've got my 39 here. So we'd add each one separately. 7 and 9 makes 16. 40 and 30 make 70. Now I could just add my 70 and my 16. And if you can do that, brilliant. That gives you your answer. If you're still a bit stuck, then we're going to look at our 16. Our 16 is made up of 10 and 6. So I've got my 70 here. I'm adding that to 10 and 6, which is the same as saying 70 plus 16. See, these two calculations are the same. 70 and 16 is the same as saying 70 plus 10 plus 6. This might be easier to do because I can combine my 70 and my 10 to 80 plus 6, and then that might make it that little bit easier to visualize your answer, 86. It is usually easier to add your ones first, because then you know if you've got a 10 that you need to add to your tens. So what you could do, if I rub all this out and go back to here, once you've done this bit, 7 plus 9 is 16, you might immediately have decided to put your 10 here with the tens from your original number. 10 plus 40 plus 30 is 80. So we cross that out, we exchange that, and now we've got 80 plus 6. So find a method that suits you. So with this example, again, we are going to add our ones, and then we're going to add our tens. Now I'm going to add my ones this time first, and I know that it makes 11. It's crossed the tens boundary, it's gone bigger than 10, so I'm going to exchange this for a 10, and I'm going to add that with my 40 and my 20 from my original number. So my 10 and my 40 and my 20 together make 70. So I've now got 70 and 1, which is 71. If I go to my other method, I've got my 40 and my 20, which make 60. And I've got my 7 and my 4, which make 11. And if I add those together, I get 71. So have a go at step 2 on your worksheet now. Step 3, we're this time going to cross boundaries with our ones and our tens, and I'll show you what I mean now. So we're going to add our ones, and we're going to add our tens. Okay. I'm going to write out my 47 is made up of, I'm going to write all in one colour now. My 47 is made up of a 7 and a 40. My 59 is made up of a 9 and a 50. I'm doing my ones first because I might have, well, I am going to have numbers to exchange. So my 9 and my 7 make 16. And my 40 and my 50 make 90. So I'd need to add my 90 and my 16. What I might also want to do is do my 7 and 9 make 16, and then take that and add that to my tens. So 10 and 40 make 50, and 50 makes 100. So I've now got 100, and I've got 6. Equals 106. If I do it over on the left side, this might be how your brain adds them. My 40 and my 50 make 90, and my 7 and my 9 make 16. So I add that to 106, or you might separate your 16 into 10 and 6 first. You still get 106. Let's have a go with another one. So let's partition, let's add our ones. And let's add our tens. So our ones and our tens. So we've got our 47 there, and we've got our 87 there. So 7 and 7 make 14. Now I might want to take my, so I'm going to add that over here as well. I might want to get rid of that 10 there, exchange it and add it down here to my 10s. 10 and 40 is 50, plus 80 is 130. And 130 plus 4 is 134. If I do it over on the left here, 40 and 80 make 120. So you may be able to add 120 and 14 to get 134, or you may need to separate your 14 into 10 and 4, like that. Again, it's 134. All three ways is 134. But hopefully that gives you some ways to visualise adding those pairs of numbers where both the 1s and the 10s cross boundaries. So they become bigger than 9, so you have to regroup and go up. Your 1s have to swap for a 10 and your 10s have to swap for 100. So you can skip right to the end to look at number bonds, or you may want to stay and watch the next part, the blue root, and have a go at that if you feel confident. Otherwise you can skip to the end of the video where we go through how to do the number bond activity. Blue root, step 1. So here we have a 4-digit number and we are just adding thousands. So if you think about it like arrow cards, the only digit that's going to change is this one. These are the two that are the same. So all the others would stay the same. I would just be adding my thousands. So I'm going to write it out over here. 3,000 plus 2,000. Okay, my 3 and my 2 make 5, and I know that it's worth 5,000. My 3,000 and 2,000 make 5,000. Nothing else changes. None of these are going to change because nothing's getting added to it. So 5,000 is just going to be added to 241. So imagine these as arrow cards going on top of here, covering that over. So 5,000 plus 241 equals 5241. Let's have a go at another number. This time I've got 300. The only digit I've got is a hundreds number. So I look at my hundreds number in my original. I'm only going to be adding those. Okay, if I look at partitioning my 3,241, that's my number partitioned. I have no thousands, I have 300s, I have no 10s, I have no 1s. That's going to stay the same. 200 and 300 is 500. That's going to stay the same. That's going to stay the same. Imagine all of these digits as arrow cards. Imagine stacking them on top of one another. And then over on the left hand side, my 2 and my 3 make 5. They're both those digits are worth hundreds. My 3,000 didn't change. My 40 didn't change, and my 1 didn't change. They're not added to anything over on the other side. There's nothing there and there's nothing there. So if you combine those numbers, you get 3, 5, 4, 1. If you look over here, you've got 1, 4, 5, 3. 3,541. Let's have a look at another example. This time I'm adding 50, so I'm just adding 5 10s. I've only got a digit in the tens column. So in my other number, that's my tens number. It's just these two that are getting added. Let's partition the first number. 3,241 40 and 1. There's my 3,241. I'm adding no thousands, no hundreds, I'm adding 5 tens, and I'm adding no ones. So that stays as 3,000. That stays as 200. 40 and 50, what does that make? Makes 90, and 1 and nothing makes 1. So if you imagine stacking these numbers up, the 3,000, the 290 and the 1, imagine them as being arrow cards. And then over here, my 4 and my 5 make 9. They're both in the tens column, so that's worth 90. None of this changed. My 3,000, my 200, and my 1, it all stayed the same. So imagine combining all those and combining all those, and the answer you get is 3. Sorry, this should be 3,000. 3, 2, 9, 1. Let's have a go with another example. This time we're just adding a ones digit. So I only need to alter the ones digit in my original number. So again, I've got 3,000, I've got 200, I've got 40, and I've got 1, and I'm adding nothing to the thousands, hundreds, or tens. I'm only adding something to my ones. So the first 3 digits stay the same. 3,000, 200, 40, and 1 and 8 is 9. Okay, over here, 1 and 8 is 9. Nothing's changing here. So actually, I can just do that, 3249, or 3,200 and 40 and 9. All of this, combine them together, I've got 3, 2, 4, 9. Okay, do you feel confident to have a go at step 1 on your worksheet now before we move on to strategies for step 2? Okay, this time we've got a 3-digit number, but we're adding a 2-digit number where we're going to have to change 2 of the digits in our original number. So here I've got a ones digit which needs to add to the ones digit, and I've also got a tens digit which needs to add to another tens digit. So I'm going to start by partitioning over here. There's my 324. I've got no hundreds to add, but I have another 20 to add, and I have a 2 to add. So I would add each bit separately. 300 and nothing is 300. 20 and 20, or 2 tens and 2 tens is 40, or 4 tens. And 4 and 2 is 6. So I just want to combine this number together. Over here, my 4 and my 2 make 6, and they are ones. My 2 and my 2 make 4, but they're 4 tens, so 40. And then this didn't need to change at all. So I need to combine this, and I need to combine this. They both make 346. Let's have a go with another example. Okay, let's start again by partitioning our number. 320 and 4, no hundreds, 30 and 5. So I have my 324 down the left and my 35 down the right. My ones add together and my tens add together. And I can see that there's only 100. My 300 is going to stay the same. My 2 and my 3 make 5 tens. and my 4 and my 5 make a 9. Over here, 300 and nothing's 300, 20 and 30 is 50, 4 and 5 is 9. So this number, these digits and these digits, if I can stack them up, imagine them as arrow cards where I recombine them, I get 3, 5, 9. So 359. Have a go now at step 2 on your worksheet using that method. Visualize them as place value cards if you need to, or think about them as a number line. I'll show you how to quickly do it as a number line in your head. So you're always taking the largest number to start with. So there's your number line, 324. You want to break up your jumps. So you could add in 5 first, and then you could add the 32nd. So 324 plus 5 is 329, because I'm just changing this digit. And then this time where I'm adding 30, I just want to change my tens digit. 2 plus 3 is 5. So the digit that's going to change is that one. And the others will stay the same. Same as before, 359. So have a go at the questions on your worksheet now. Step 3, we're back to a 4-digit number and we're changing 2 digits in our 4-digit number. As before, the key to it is to think about matching up the digits that sit in the same place value. So I've got a 100 digit, which I need to add to the hundreds in my other number. So my 3 and my 2, those both need to add. And my 2 and my 5, those both need to add. My 3,000 is going to stay the same. So I've got 3,000 here. Then I've got my 200 and my 300, which is going to make 500. Then I've got my 50 and my 20, which is going to make 70. And then I've got my 4 and my nothing, which are going to make 4. And then I would need to recombine that number. If I partitioned it, 3,000, 200, 50 and 4, that's my 3,254 partitioned. If I can partition my 320, there's no thousands. There's 300, there's 20, and there's no ones. So if I go through each line, my 3,000 stays the same. My hundreds become 500. My tens become 70. And my ones stay as 4. Both numbers end up being 3, 5, 7, 4. Let's have a look at doing that using a number line. So if I draw in my number line, I put in my largest number at the beginning, and I want to think about partitioning my 320. So let's do a jump of 20 first, and then let's do a jump of 300 next. So if I'm adding 20, I'm thinking about changing the number in my tens column. So 20 is 2 tens. That means the 5, this digit, is only going to change by 2. So it'll become 3274. This time I'm adding 300. That means the number in my hundreds column will change. So the digit that's worth 100 is 2. That's going to change by 3. So it will become 3574. And again, it's the same number. Let's have a go with another example. This time I'm adding 3,200. So again, let's have a look at the 2 digits that we need to change. So I've got my 3,000s in both numbers, and then I've got hundreds in both, and actually my thousands and my hundreds are the same. These are not going to change. They're going to stay the same. My 2 and my 2 make 4, so that was 400. And then my 3,000 and my 3,000 become 6,000. So that all makes your answer. And then if we partition it over on the other side, I've got 3,000, 200, 50 and 4. I've got 3,000, 200, nothing and nothing. 3,000 and 3,000 make 6,000, 200 and 200 make 400, and then these two don't change. So all these digits and these digits is the same. It ends up as being 6, 4, 5, 4. Do you feel confident to give that a go now? I'll just show you one last method on a number line for that number if you're not confident already. So you could be thinking about partitioning it like I've done here, or you might want to think about keeping the first number the same, which is what you do on a number line. Keep the first number the same, 3, 2, 5, 4, instead of partitioning it, and then think about adding your 3,000, then adding your 200. So I'm not going to colour code it this time. 3,000, it's that digit that's changing by 3. So it's 6, 2, 5, 4. And then I'm adding my 200. 200, it's this digit that's changing. It's changing by 2. All the other digits stay the same because I'm not crossing any 10s. So if that 2 became bigger than 9 when I added this, then it would my thousands digit would change, but it's not. It's 6, 4, 5, 4, exactly as before. So hopefully you've got enough strategies there to have a go at your step 3. This is what you need to know even by the end of year 6, how to start being able to add larger numbers in your head by thinking about the place value of each of the digits, and also being able to hold on, retain the memory as well. We're next going to move on to the number bond activity. So in this activity, I want you to find pairs of numbers that add to either 100, 1,000 or 10,000. Now, if you've been doing blue route, you can still do green and yellow. If you've been doing yellow route, you might want to try blue. You might want to try green. And green, you might want to try yellow. You might want to try blue. You can try the route that you're doing, but you can also try the others as well. Okay, here's the number 36. If I wanted to make 100, what would I need to add to it? For this activity, it's quite... I'd recommend you visualise using a number line if you don't have strategies already. So I'd think about how I'm going to get to 100 from 36. I would first think about rounding up to my next 10. So after 36, my next 10 is 40. So I'd think about what I need to get there. And I need 4 to get there. Then from 40, I would think about how many 10s I need to get to 100. So 50, 60, 70, 80, 90, 100, I had to add 6 10s or 60. And then I can add up these 2 jumps for my answer. So my answer is 64. If there was a 36 on my page, I'd need to look for a 64 to make a matching pair. Okay, what about if I was trying to make 1,000 though? Could I add something to 36 to make 1,000? I'm still going to round up as I did before. First of all, let's get to the nearest 10. I add 4. Then let's get to the nearest 100. I add 60, because I did that earlier. And now from 100, how do we get to 1,000? I add 900. And if I add all three together, 960 and 4, I've got 964. So a number line is a really useful way to visualise how to make your 100 or thousands. We could even do this with 10,000. And I'm actually going to leave those first two jumps in, and I'm just going to change this to 10,000. I'd still jump to 40. I'd still jump to 100. I'd still jump to 1,000. That was 900. And from 1,000 to 10,000 is 9,000. And if I add all those up together now, I've got 9,000 plus 900 plus 60 plus 4. So I've got 9964. At any point, if you feel confident with giving your questions a go, then go for it. So have a go at using number bonds, having your number bonds, but also using number lines, visualising arrow cards. When you think you've got an answer, add them and check it. So always check. So let's have a go with 350. Now I want to, this is bigger than 100, so we're trying to make 1,000 or 10,000. I'm actually going to put a number line above it. To make 1,000, I would think about rounding to my next 100. What did I need to add? 50. Then from my 400 to my 1,000, 500, 600, 700, 800, 900, I needed to add 600. Add the two together, the answer is 650. So what about if I changed that end number to 10,000? I first jumped to 400 by adding 50. I then jumped to 1,000 by adding 600. From 1,000 to 10,000, I'm adding 9,000. Add them all together. Is 9650. Are you getting the hang of it? Let's have a go at another couple. Let's see if we can make 10,000 from some other numbers. Okay, I've got 4,100. Let's put that into a number line. I want to get to the number 5,000. What would I need to add to 4,100 to get to 5,000? If you look, it's only the next 1,000, so I need to change my hundreds digit. I'm going to add 900 to get to 5,000. Then from 5,000 to 10,000, it's a nice easy jump. 5 to 10 is 5,000. So I had 5,900, which is the same as 590. So if I had, it's the same as 5,900. Always check. Everyone makes mistakes. So always check over your answers and think, did that make sense? And that did not make sense to me. So I've spotted that I was a bit too quick there. So 5,900. So hopefully you've got a few strategies there to help you find the pairs. Now on this activity, there are some numbers that will be pairs for the hundreds, the thousands and the 10,000. So really check if you're having a go at doing all three of them, you can use some numbers twice. Good luck with that. I hope you've learnt something new during this lesson today. If you'd like to go further with your mental calculations, on our Pocket Private Tutor app, which is available free to download in the Apple and Google Play stores, there are 49 different lessons. The lesson which immediately comes after this is performing mental calculations. It will also include multiplying and dividing and how to build some strategies for being able to do that mentally. You will get a worksheet, a lesson video, which is just under 25 minutes long, and you'll also have four examples of past SATs questions relating to performing mental calculations. So if you'd like to go to the next step and look at the objectives, which is related to year 6, then have a look in the Google Play or Apple store where you can download our app. You can try out 6 lessons for free. And if you want to access this lesson, it will be $4.99, and that gets you access to the whole library for a full month.